So today we're going to look at the second half of lesson 13-2, and we're going to concentrate on angles of elevation word problems and angles of depression word problems. So essentially, you're going to create, for each of these word problems, you're going to create your own triangle. And you're going to go from one object to another object. And so like on this one, it says the angle of elevation from a fishing boat to the top of a lighthouse. So imagine that this person's a fishing boat, so you'd have a fishing boat here to the top of the light post. So it's telling you the line of sight. The boat would be looking up at the top of the light post. So that's why this is considered the line of sight. You always have to have a line parallel from the eyes, parallel to the ground. This is your baseline, if you will. And so if you think of elevation, elevation means to go up. So from this baseline, to get to the line of sight, we went from the baseline up to get to line of sight. So that's an elevation. If you look at the angles of depression, so in this particular picture, you have a fire is spotted from a fire tower. So here's a fire here. Again, your baseline is going to be parallel to the ground from the eyes. So there's the baseline. And then this is a line of sight looking from the top of a tower down to the fire. So you're going from this baseline down to get to that line of sight. So that's an angle of depression. People who are depressed tend to look down. So I'm going to concentrate on these word problems that are angles of elevation. So I'm going to do 2 of them with you, and then you're going to do the other 2 on your own, and then we'll do the angles of depression problems. So for this one, you can be as creative as you want to with your pictures, but you must draw a picture for your word problems. Base thing is to draw something that goes from something to the other thing. So try not to draw just a plain triangle. And as you know, I can't draw, so here we go. The angle of elevation from a fishing boat to the top of a lighthouse. So I am going to draw a fishing boat and a lighthouse. So there's water, and then this is going to be, now clearly a fishing boat does not have eyes, so we're going to assume that it's at the bottom of the boat. So my baseline is going to be right here, and then since it's elevation, we're going to look up, right? So we're going to look up at that top of that tower, and it creates this right triangle where the right angle is there. So this is going to be my angle of elevation. And let's see what they tell us. So from the fishing boat to the top of a lighthouse, that angle of elevation is 5 degrees. So right here, that angle going from the baseline to the line of sight is 5 degrees. So I'm going to put 5 degrees here. So that is my angle of reference. And then it goes on to say if the top of the lighthouse is 161 feet above sea level, so here's sea level to the top, that is your 161 feet from top to bottom. And then the question asks for, and this is where your variable comes into play, how far is the boat from the lighthouse? The distance the boat is from the lighthouse is this parallel distance. It is not this distance here. So distance from one object to another tends to be parallel, and so that is where we're going to put our x. All right, so if this is my angle of reference, then, and I'm touching this angle right here, I'm touching this side here because this is the hypotenuse, it's across from the right angle. This is not the side adjacent, this is the side adjacent. So I'm going to put adjacent here, a little hard to read. And then this side here is the side opposite. So OPP. So we're going to do the same thing that we did yesterday, same exact process. Since I have an O and an A, O comes first and then the A. And of course in SOHCAHTOA, T belongs with the O and A. So that's why we're choosing tangent of some degrees equals your ratio. So we're going to talk to ourselves. We are tripping on acid, right? And so our degree is the 5 degrees. So that goes here. And then our ratio opposite over adjacent is going to be the 161 over the x. And so remember, we're going to turn this into a proportion and cross multiply. So x times the tangent of 5 is x times the tangent of 5 degrees equals, and then 1 times 161 is 161. To solve for x, we need to undo multiplying by the tan of 5 degrees. So we divide by the tangent of 5 degrees. So those cancel. And so I get x is approximately equal to, and of course, this is what goes in your calculator. Remember when you pick up your calculator to check your mode, to make sure that your mode is in degrees, that degrees are lit up. And then I'm going to put in 161 divided by the tangent of 5 degrees. And I get oops, that's not what I want. I get 1,840 0.2, and then because they gave us the tower's height in feet, this must be in feet. So make sure you put in your units of measure. All right, then I'll do one more with you. So for this one, it says the angle of elevation from the bottom of a slide to the top of the slide. So I'm going to do my best to draw a slide. So here's the ladder, right? Here's my ladder. And here's my slide. And so it does create this triangle, and I think I'll put the triangle in blue. So I really have this triangle, you know, that's right here, basically. And it says the angle of elevation from the bottom, so here's the bottom of the slide, to the top. So it's going from this baseline elevated to the slide itself. So it's going in this direction, right? So that's your angle of elevation. And they say it is 44 degrees. So here is your angle of reference right there. And then it goes on to say if the top of the slide sits 16 feet above the ground. So the top of the slide is 16 feet. Let's squeeze that in here. From top to bottom. Find the length of the slide. So this is the length of the slide. So then your x is going to go here. So if this is my angle of reference, then for this angle of reference, this side right here is across from the 90-degree angle, so this must be my hypotenuse. And this side is opposite. So I've got, where am I going to put that? OPP. I guess I'll squeeze it in there. So off here to the side, I have an O and an H. So goes with O and H. So that means I am choosing sine. So I have sine of some degrees equals a ratio. And so then you've got some old hippie. And now we're going to put in our values. Our angle is 44. Our side opposite is 16. And our hypotenuse is the x. So once again, we're going to create that proportion, and we're going to cross multiply. X times the sine of 44 gives us x times the sine of 44. And then 1 times 16 is 16. And then to undo multiplication, we are going to divide both sides by the sine of 44. And so what you're putting in your calculator is this, right? And so we get x is approximately equal to, and then 16 divided by the sine of 44 is approximately 23.0, and then that's in feet. All right, so now I want you to try the 13 and 14 on your own. So pause the video and then restart it to check your work. All right, so I'm going to run through 13 pretty quickly. You have a 10-foot ramp is used to unload furniture from a truck. Here we go, best picture ever. That's a great truck. There's the ramp. Let's just assume my wheels are touching the ground. So a 10-foot ramp. So then we know that this ramp here is 10 feet. So a 10-foot ramp is used to unload furniture from a truck if the back of the truck sits 3 feet off the ground. So that means this part from here to here is 3 feet from top to bottom. And this is my right angle. Find the measure of the angle that the ramp makes with the ground. Well, here's the ramp and here's the ground. So ground, ramp, ramp, ground. You can see the angle that's being made, and that angle is right here. And we are going to call that theta. So let's label our sides. So according to this theta, this would be side opposite and the hypotenuse. So I have OPP and then hypotenuse. So that means that I have O and H. And since I have O and H, that's so I'm choosing sine. So sine of blank degrees is equal to a ratio. So some old hippie. And then we are going to put our values in there. So our value for our degrees is just theta. We don't know the degrees. And then opposite is 3. And hypotenuse is 10. So for this one, remember when you don't know the angle of measure, you have to use the inverse sine. So it's actually less work. So theta is equal to the inverse sine, and then big parentheses, and you're going to take this ratio and put it in here. So the 3/10 goes in here, and then this is what you are putting into your calculator. Remember, to get that inverse sine, you have to use the second function key. So second sine, and then 3 divided by 10, and then enter. And so our answer is theta is approximately equal to 17.5 degrees. So that is the angle that the ramp makes with the ground. All right. Oh, I apologize. You're not doing 14 on your own. You just did 13 on your own. 14 is an angle of depression. So let me go through this one with you, and then I'm going to let you try 15 and 16 on your own. But let's go ahead and draw our figure. So a fire is spotted. Actually, let's use this figure here, because this is a perfect figure right here. So let me make this a smidge smaller. Oops. Smidge smaller, so I can get all that in there. All right. So a fire is spotted from the top of a 125-foot tall fire tower. So that means, move this over. That means that this is, if I can draw it in here, 125 feet. That's tall. If the angle of depression So you can see here, here's the line of, this is his baseline because it's parallel to the ground. And then angle of depression, he's looking down from above down to the fire, so he has to be looking down. So his line of sight would be here. Line of sight is always diagonal. And so this is that angle of depression. They say the angle of depression to the fire is 19 degrees. So let's put in here 19 degrees for that angle. And then remember, if you have two parallel lines cut by a transversal, I don't like my angle of reference up top. I like it at the bottom. You've got these two triangles that are created, one here and one here. So I like to move this. Remember, alternate interior angles are congruent on parallel lines cut by a transversal. So if that's 19 degrees, this is 19 degrees here. And I prefer that to be my angle of reference, but we'll get to that. The question is, how far is the fire from the base of the tower? Remember, just like that boat, how far was the boat from the base of the lighthouse? This is the fire, and this is the base of the tower. So they're talking about this horizontal line here, so that's what you're going to let be X. So our line of sight, or I'm sorry, our angle of reference is the 19 degrees, and then we are going to label our pieces. So from here, if I'm touching this side here, here's the right angle, is not across, right? This side here is across and right angle. That's a hypotenuse. So if that's a hypotenuse, this side here must be adjacent. So adjacent. And then this right here, this is opposite. So I'm going to put OPP. And so I have an O and an A. And so, ka, toa. So T belongs with the O and the A. And so that means we are going to choose tangent of some degree equals some ratio. So tripping on acid. We're going to put our values in there. Our degree is 19. Our opposite is 125. And our adjacent is X. So remember, this is going to cause us to have two steps. So we're going to create a proportion, cross multiply, and so I get X times the tangent of 19 degrees is equal to 1 times 125, which is 125. To solve for X, we have to undo multiplication by dividing by the tangent of 19 to both sides. And so the tangents cancel, and we have X is approximately equal to, and of course you are going to put this part into your calculator. So 125 divided by the tangent of 19. So X is approximately equal to 363.0. And that's how far, so that's in feet. That's how far the tower is from that fire. Okay, I would like you to do 15 and 16, which is finishing up these problems. So draw your picture, pause the video, draw your picture, and then check. Okay, so I'm going to go through these pretty quickly. So an airplane is flying at an altitude of 8,900 feet. So here's my airplane. It's an awesome airplane. If it's flying at an altitude of 8,900 feet, then altitude is height. So altitude is a vertical measure that is perpendicular to the ground. So that's 8,900, and that's feet. And then it says the pilot spots a raft floating in the water at a 28-degree angle of depression. So the baseline for this airplane is in this direction, right? That's the baseline. And then it sees this raft somewhere out here, right? And so to see that raft, it had to look down right? It had to look down, so it's depressed. And so it saw this raft here and creates this triangle. And so let's label what else we know. Pilot spots a raft floating, and the 28 degrees is that angle of depression. So right here is the 28 degrees. So 28 degrees is that angle of depression between the baseline here and then looking down. Remember, I don't like my angle of reference up here. I really want it down here. And if you have two parallel lines cut by that transversal, that's what enables me to move that angle of reference down below. And the question says, what is the horizontal distance from the airplane to the raft? This represents your horizontal distance. This would be the diagonal distance. This is a horizontal distance. So my line of sight, or my angle of reference, I don't know why I keep saying that, angle of reference is 28 degrees. And then let's label our pieces. So this is our hypotenuse because it's across from the 90, so that one I don't have, so I'm not going to use it. That means that this one is adjacent. And then this one is opposite. So I have OA. So, ka, toa goes with the OA, so I choose tangent of some degree equals some ratio. So we are tripping on acid. Put in your values. The degree is 28 degrees. Your opposite, 8,900. And your adjacent is x. Wow, they all seem to be in the denominator today. We're going to cross multiply. So x times the tangent of 28 degrees. 1 times 8,900 is 8,900. To solve for x, divide by the tangent of 28 to both sides. So the tangents cancel, and we get x is approximately equal to, and of course, this is what goes into your calculator. So 8,900 divided by the tangent of 28 degrees. So we end up with, oops, that's not what I wanted. I was trying to move that. All right, so x is approximately equal to 16,738.5. That's a 0.5. Put the point there, 0.5, and then that's in feet. So that's your answer to that one. And then if you haven't done 16, pause the video and do 16 and then restart the video. So with 16, Max is sitting in the stands at a baseball stadium. So here's the baseball stadium. So let's just assume he's way up here sitting in the stands. It's good enough for me. He catches a foul ball. So he catches a foul ball and decides to throw it back to a player standing on first base. So here's the player standing on first base. That was his mitt, in case you didn't know that. If the horizontal distance from Max to the player, so this is a horizontal distance from here to here. We usually do it on the ground. So that horizontal distance from here to here, and mind you, our triangle is going to go from here to here, and then his baseline is from here to here. Okay, so because Max is looking down at the baseball player, we are going to end up having an angle of depression right there. All right, so he catches a foul ball and decides to throw it back to a player standing on first base. If the horizontal distance from Max to the player is 61 feet, so this is 61 feet, and the ball travels 76 feet. Well, he's throwing the ball in this direction. He doesn't throw it this way. So this is the path that the ball travels. So that path is 76 feet. So I'm going to put 76 here. What is the angle of depression from Max to the player? So this is your angle of depression right here. We don't know what it is. And remember, if we have two parallel lines cut by this transversal, alternate interior angles are congruent. So I'm going to put the angle of depression here, which it actually becomes an angle of elevation, but that's okay. All right, so also remember that our right angle is here, okay? And let's label our sides. So if this is my angle of reference, right? Then, and I'm touching this, this is the diagonal line that happens to be across the right angle. So that has to be our hypotenuse. And I am also touching this side when I touch the angle, so that is your leg adjacent. So for this one, I have AH, H always comes second, and so ka, that must be ka, so we're choosing cosine. So cosine of blank degrees is equal to a ratio. So caught another hippie. So our degree is theta, our adjacent is 61, and our hypotenuse is 76. So as soon as you don't know your angle of reference, you're using the inverse trig function. So theta equals the inverse cosine, and then big parentheses, and then you're putting that ratio 61 over 76 inside. And so this is what goes in your calculator. All right, so second cosine to get to that inverse cosine function of 61 divided by 76. And so we get 36.6. So theta, oops, not the theta I want, theta is approximately equal to 36.6. And that is in degrees. And that is it. Please let me know if you are struggling on the word problems, but you're going to finish worksheet 13.2, which includes 1 through 14, and that's also the word problems 10 through 14. So text me with any questions.